Good afternoon. Welcome to today's Engineering Science N4 webinar, hosted by Macmillan and Chopin Publishers. My name is Gyan Krishna. I'm the National Sales Manager. In today's webinar, we are going to take you through all the changes in the curriculum and assist you in preparing for its implementation in your classroom. The platform we are using is GoToWebinar. There's a control panel on your right-hand side. Please feel free to post your questions and these will be answered later. Our sales team have been to your campuses with sample books. You can also view them online using the link provided in the chat box. Just some background on today's presenter. His name is Ruvi Nair. He's an engineering TVET lecturer with many years of valuable experience to his name. He's also a national chief marker, a trade test assessor, former civil technician, and he's also authored a number of native engineering textbooks. So it's over to Ruby to start today's presentation.
Thank you, Gyan. As Gyan has mentioned, my name is Ruby Nair. I'm in the TVET sector. I lecture in Newcastle in KZN, and it's a great pleasure to do this presentation for you this afternoon. I want to welcome you once again, as Gyan has. I want to encourage you to grab a cup of coffee or maybe something cold and enjoy the session. I do encourage you to participate in the activities that we have. I also encourage you to stay focused, and please do not feel shy to ask any questions in the chat. This will be addressed in the Q&A section. In this webinar, we plan to review new curriculum outcomes, discuss the impact of the changes, and show you how the title Engineering Science N4 will support your teaching and, of course, support learning in the classroom. Let's firstly start with the author of this textbook, who is Martins van Rensburg. Martins van Rensburg is a well-respected textbook author with over 35 years of lecturing experience. Martins possesses numerous tertiary and postgrad qualifications, including BSc Honours in Mathematics. Martins has written maths books from N1 to N6, as well as engineering science from N1 to N4. If you've been into the TVET sector for a while now, the chances are you have definitely come across a book that Martins has written. Further to this, Martins is a former examiner in engineering science, which puts him in a great position to actually write this book. As Gyan mentioned, I'm Ruby Nair, also lecturing in the TVET sector. Okay, before we start actually looking at the syllabus and the changes, etc., let's firstly look at the subject Engineering Science N4. Engineering Science N4 is a core subject for all courses except for civil engineering. So basically, if you're doing mechanical, electrical, or chemical engineering, engineering science is a compulsory subject at N4. It is also a government-triggered subject, meaning you will not be certified as a government engineer if you did not get at least 50% for engineering science N4. It is a prerequisite for most N5 and N6 engineering subjects, example, power machines. It is a general subject covering various trades, meaning it is not a trade by itself. Some industries will not even employ artisans without having completed engineering science. This is the importance of engineering science N4. Apart from maths, it has the most registered learners of all engineering subjects, which naturally will make it the most written engineering subject in the native syllabus. Looking at the new curriculum for engineering science N4, implementation date May 2022, meaning the exams that are just rounding up now will be the last engineering science N4 paper written on the old syllabus. Before we make any comparisons, I'd like us to just consider what an outcome-based syllabus actually is. In an outcome-based syllabus, the focus on outcomes creates a clear expectation of what needs to be accomplished by the end of the course. Students will understand what is expected of them. Teachers will know what they need to teach during the course. And as I'm reading this, if you think about the old syllabus, there were not any clear outcomes for lecturers, teachers, or even students to make use of. I have in front of us an extract from the old syllabus. There was nothing wrong with the content of the syllabus, but the issue here was that there was no specific learning or specific teaching outcomes. The old syllabus did not give enough information about the content that needed to be taught. If we look at this, it's in the form of a sentence. It's not in the form of a table. There isn't a clear outcome to tell you exactly what will be assessed, exactly what should be taught. There was no specific learning outcomes. There was no clear guidance to lecturers. So lecturers did not know the bounds of the syllabus, exactly how far to go, where to stop, or how much to teach. This further led to very tricky and sometimes out of the syllabus questions appearing in the exams. Now a thing like that has a very bad effect on learners. As learners fail, it has an even more serious effect on lecturers, as you are questioned about your pass marks and why are your learners performing so badly, etc. Now, the moment we start comparing the new syllabus, if we look, the first part of the syllabus, it gives you a general aim. On completion of this module, the students should be familiar with solving analytical problems relating to the practical situations where two objects move horizontally at a constant velocity in different directions. Students must be able to determine the resultant velocity, shortest distance, time intersections, overtaking, and actual velocity. Now this, as we see, is what an outcome-based syllabus is. The focus on outcomes creates a clear expectation of what needs to be accomplished. So at the beginning of the syllabus, we have a clear general aim on exactly what should be accomplished. The syllabus is written in the format of a table. On the left-hand side, numbered is your learning content, and on the right-hand side is your learning outcomes. And it says students must be able to. So it comes back to the second point, students will understand what is expected of them. And of course, teachers will know what they need to teach during the course. Every learning outcome is clear. Solve problems dealing with constant linear motion analytically, calculate, do calculations, etc. Instructions in the syllabus are very clear. It shows the bounds of how far a lecturer should go when teaching. Now let's look at what are the advantages of a syllabus in this format. The learning outcome is specific and clear. There's clear guidance to the lecturer. There leaves no room for uncertainty. There is no gray area. Should we teach this section? Excuse me, should we leave this section out? There isn't a gray area. Now, furthermore, how does this affect the exams? The examiner cannot deviate from these outcomes. There is strict moderation and quality control mechanisms and tools that make sure the examiner sets the examination based on this document in front of us. And one of the best parts is it makes sure there is no, I would like to call it bombs in the exam, where questions come out that were not in the syllabus, were possibly from a higher level, which unfortunately did happen in the old syllabus due to the nature of the syllabus. I also want to encourage any lecturers at this point for the exams going forward. If there is any deviation from the specific syllabus that you see here in front of you, you have a right to report it to TVET. The general aims of the new syllabus. Students should be able to build on the basic knowledge attained in engineering science N1, N2, and N3. So it is a continuation of engineering science from N1, N2, and N3. Students should understand each basic scientific principle. Students should be able to integrate knowledge of various systems and components in their applied subject. I will speak a bit more on this shortly. Specific aims: to introduce students to apply the scientific principles mastered to his or her specific trade theory, be able to apply SI units and derived units correctly, demonstrate the understanding of the subject content through the application of acquired knowledge, be able to solve problems by using subject content. Now, to understand the subject, as I mentioned, engineering science is not a trade on its own. What we are doing here in engineering science N4 is preparing the learners by building on their knowledge firstly, by secondly teaching them how to apply the scientific principles and the SI units, all in order to use this in their trade that they are studying. So if they are studying mechanical engineering, we are setting the basis for the calculations that will be used in mechanical engineering. If they're studying electrical engineering, the same applies. The same scientific principles that we are teaching them at this level will be used in the higher levels. So it is a major foundation subject in the course. Hence, it's a very important course, and learners need to be very well versed in engineering science N4 if they are going to complete N6 and eventually graduate. Looking in detail on the topics, specific aims to enable students to acquire in-depth knowledge of the following content. 1.2.1, kinematics. 1.2.2, angular motion. 1.2.3, dynamics. 1.2.4, statistics. 1.2.5, hydraulics. 1.2.6, stress, strain, and Young's modulus. 1.2.7, heat. Okay, so we have a general idea of the topics that will be covered in this new syllabus, and we can see that it's definitely going to be an outcome-based syllabus. Now, comparing the learning content with the new curriculum compared to the old curriculum, you will notice very subtle changes in the percentage weighting, and the names of the topics have not changed at all. Topic 1, kinematics, was 12% of the total 100%, and it's now changed to 15%. Angular motion used to be 9%, it is now 12%. Dynamics used to be 12%, it's now 14%. Statics remain the same at 15%. Hydraulics, we see now with hydraulics, it's a relatively a significant drop from 20% to 15%. Stress strain and Young's modulus remain the same at 14%, and heat remains the same at 15%. So at this point, if you were worried about the new syllabus, whether you should actually be going and doing some further studying in university and stuff, I'm here to tell you that's not necessary. The topics are the same. There is slight adjustments with the nature of the questioning, but the major change in the syllabus is that the outcomes are clear. Curriculum 2022 changes to the content. Change in the assessment standards. Knowledge was reproduction and was weighted at 60%. Understanding was analysis and was weighted at 25%. Evaluation was weighted at 25%. Okay, looking straight into topic 1. Topic 1 is kinematics. The topic weighting is 15% of the total 100%. Unit 1.1, relative velocity, constant linear motion problems, Pythagoras or sine or cosine rules. Unit 1.2, resulting velocity, calculate the resulting velocity and direction of a maximum of two vectors. Calculate the time to reach a certain destination. Unit 1.3, projectiles. Calculate projectiles that are launched horizontally from a certain vertical height or launched at an angle from the horizontal landing on the same horizontal plane. Calculate the maximum height reached by an object as well as the time of flight and range. Calculate the height and velocity at any point of the projectile path. In our title, N4 Engineering Science, our module 1, we have allocated 32 pages of content for the section. We have 18 fully worked examples, 4 activities, 1 summative assessment, a module summary, and like all our modules, we have video and resource links. Now, all our topics, we begin with the starter activity and an overview. A starter activity is something that sets the scene for the topic. The starter activity may not be a specific scientific question, but the question encourages thinking about the topic and gives the learner a sense as to exactly what we are going to cover in the topic. There is a lot of technical terms in engineering science, yes, and for this reason, we clearly have definition and text boxes giving us the definition of a term. Now we must remember, there are a lot of artisans that have been in industry for 20 or 25 years, and they've been sent by their company for reskilling. Now we consider these people when we are writing the book, knowing that a lot of these terms may be new to them. It would not be fair to go on writing and discussing a term without explaining it. We also know and understand the language barrier that we have in our country. A lot of learners are coming from rural areas where English is definitely not their first language. It is for this reason that we clearly have the definitions and pictures to even show the learners exactly what we are talking about. This is an example of the definition that I'm talking about. Resultant, the single force that can replace 2 or more forces and still do the same amount of work. Throughout this chapter, throughout this book, you will find these text boxes with clear definitions. Now, coming to this point here, 18 fully worked examples. It is very rare in an engineering book that you will see so many examples. But the vision that we have is that we do not want to leave work for the learner. We want to give the learner as much of the examples as we possibly can. We do not want to do the situation where we do 2 examples and we say, the rest of the examples, you just need to change the subject or formula, or you just need to change this value. That's not what we intend. We intend to give as much knowledge as possible to the learner. In doing this, you as a lecturer, we are giving you maximum support. You do not have to have our book and go and do other research and find other examples. No, we are covering with these 18 examples in this topic most, if not all, of the scenarios. And if you look at our solutions, there is no spaces in between. We're not leaving parts to skip steps and just get to the final answer. No, that's not what we are doing. We are giving it step by step. We are breaking down the calculations. Further, we are even graphically representing the answers. Our aim here is for the learners to pass. And in doing so, we are also giving the lecturers the support. Looking at Module 2, Angular Motion, new content, Unit 2.5, Torque, Work Done, and Power. Calculate accelerating and decelerating torque if the moment of inertia of an object is given. There is 18 pages of content in this particular module. It is 12% of the total weighting. There's 8 fully worked examples. There's 3 activities. There's 1 summative assessment. There's 1 module summary. And there's, of course, video and resource links. You will notice in this module and throughout the book, we have photographs of the various objects and things that you would find in this topic. Bear in mind, some learners have never seen a flywheel in their life. It is our duty as lecturers to do our best to demonstrate, to illustrate, and explain exactly what a specific thing may be. In this picture, figure 2.4, we have a picture of a flywheel. We have a definition of a flywheel. We do not want to leave it to the learner's imagination. We want the learners to understand exactly what we're talking about. I've also just extracted a picture, a diagram from the module, and you'll see that throughout this book, and particularly in this module, we are explaining by means of diagrams, by means of pictures and graphs. There's 3 activities. Now let me touch on these activities. These activities are strategically placed in the module. We don't expect as a lecturer and as a student to go through the whole module to keep learning, and not actually assessing yourself. Now, as I say, these activities are strategically placed at intervals where we can test the learner to see how far the learner has come and whether the learner understands. The activities are in the student book in the form of questions, and the answers are in the lecturer's guide, which I'll touch on later. The activities is a good instrument for you to measure the progress of your learners. It can be used to see whether learners are coping, whether some sections need to be retaught, and it can even be used by you as a lecturer to base your questions when you are setting tests. Module 3, Dynamics. Unit 3.1, Newton's 3 laws of motion. Apply Newton's second law of motion. Sketch free body diagrams of vehicles traveling on horizontal or inclined planes while moving at constant speed, accelerating or decelerating. Calculate the tractive effort and braking effort required for motion on horizontal and inclined planes with regard to practical problems, including gravitational force, rolling resistance force, and inertia force. Unit 3.2, calculate kinetic and potential energies and energy loss. Unit 3.3, apply the conservation of energy equations for vehicles traveling due to its own weight on horizontal and inclined planes, no tractive effort or braking effort applied. In our book, when it says sketch free body diagrams of vehicles, you will find that for every example requiring this, we have sketched free body diagrams using computer-aided programs to draw this. We are not leaving it to the lecturer by merely putting the example without the diagrams. We're giving as much possible information for you, the lecturer, and for the learners to grab onto. There's 24 pages of content in this particular module. There are 13 fully worked examples. There are 3 activities. There's one summative assessment, 1 module summary, and 1 video and resource link. This topic is 14% of the 100%. I will use this module to explain the concept of the summative assessment. As the activities assess the learners at intervals, the summative assessment is a tool and a test basically at the end of a module. So once you have completed the module, once you have done, in this case, the 3 activities, you now, as a lecturer, can give the learner the summative assessment to do. Now, the summative assessment will not just cover one particular part of the module. The summative assessment will cover the entire module. And when the author wrote these questions for the summative and, of course, for the activities, knowing that our author has been an examiner for many years, he knew exactly the type of questions to ask the learners to test whether they have been, the learning outcomes have been achieved in this particular module. The summative assessment questions are similar to examination questions. There are marks allocated to each question, and the answers for all of the questions are in the lecture's guide. If we look at this, I've taken an extract from module 3 on the dynamics. Apart from teaching the learning outcome, in our book, we also have tips to help solve problems. As I mentioned, our author is very experienced in lecturing and assessing the subject at a national level. So the tips that he is giving here is based on his experience on where learners are lacking or where learners can improve. Like for this one, an example, it says tips to help solve problems, sketch the diagram and indicate all forces. So obviously this tips is based on his experience on what learners have not been doing. I also want to highlight here in this particular solution, the extent that our worked examples go into in our textbook. If you look at this, our maths is very clear. We have interim answers, we have final answers. We're not missing any steps at all. If you look at these calculations, we are not jumping from one step and expecting the learner to figure out how the final answer was achieved. And from my experience as a lecturer, once we start skipping steps is when we start losing learners. When I say losing learners, learners don't understand where the final answer came from. And of course, we have many diagrams, like in this particular example, to further explain to the learners. Module 4, statics. New content, Unit 4.1, simply supported beams and cantilevers with point loads and uniformly distributed loads. Calculate the point of inflection. This has been moved from N5 to now N4. The topic weighting is 15%. If you look at this module, 44 pages of content is covered. And one of the reasons for that is, considering Unit 4.1, simply supported beams, cantilevers with point loads and uniformly distributed loads. Now, we as lecturers will know the combinations of examples that can occur here. We could have an example with point loads only. We could have an example with uniformly distributed loads only. We could have one with point loads and uniformly distributed loads. We could have a cantilever. The combinations here is really a lot. So considering this, we have 14 fully worked examples for statics in module 4. And you'll notice our activities for this module has increased to 4 activities because we know the nature of this particular module. Learners need to be assessed step by step to check their progress. 1 summative assessment and 1 module summary, video and resource links, of course. Now, I've taken an extract here from module 4, statistics, to show you that we also understand that there isn't just one particular way for a question to be answered. On the left-hand side, we have this beam here. As I was mentioning, there's various kinds of examples. If you look at this beam, it's a cantilever beam with a uniformly distributed load as well as point loads. In our solution, the conventional solution, we have the step 1, moments about A, step 2, moments about B. But we also consider the alternate solution. Remember, this subject, as I mentioned in the beginning, is covered in the whole of South Africa. It's the most written and the most taught engineering subject in South Africa. So naturally, there's not going to be just one answer for each question. If you look here, we have considered the alternate solution, which of course will give us the correct answers. Now, what I found in previous engineering books, the shear force diagram and the bending moment diagram was not always done. It was done maybe for one example. It was left to the learner to figure out the rest of the examples. In our book, we made sure that where required, the shear force diagram, the bending moment diagrams were clearly drawn and in line with the beam. So learners were not lost along the way. Learners were not required to do their own drawings and have nothing to compare it with. Module 5, hydraulics. Okay, this is the topic that has dropped by 5%. And even though it dropped by 5%, you will notice there still is a lot of content that needs to be covered. And 40 pages of content was covered in this module. Hydraulic pumps calculate the theoretical and actual flow rate of reciprocating pumps. Calculate the rotational frequency of a pump to deliver a given flow rate of water. Calculate the time taken to fill or empty a reservoir for a given flow rate. 5.3, hydraulic accumulators. Name the types of accumulators. State the functions of an accumulator in the hydraulic system. All right. As many of you are lecturing in for engineering science, we will know this is one of the biggest topics that has ever been in engineering science. The fact that it has dropped by 5% of the overall percentage does not really affect how big this particular topic is. Hence, as I've mentioned, we have covered 40 pages of content. But the amazing thing in this particular module is that we have 20 fully worked examples. Yes, that's right, 20 fully worked examples. We understand the nature of this module. We understand exactly how many types of examples that need to be covered. And hence, when the author wrote this book, he has put in 20 fully worked examples. It's such a module, and for those of you who have been lecturing this for many years, we understand the nature of questions that can occur. It's a topic that opens up to various questions, and sometimes we've all been learners at one stage. We face a point as learners where we start leaving out things because we have to go and look for the answers or look for the examples. It's also for this reason that we have put so many fully worked examples in this particular module. There's 4 activities. There's 1 summative assessment, a module summary, video and resource links, of course. Now, this topic is based on hydraulics, which is not something that can be easily demonstrated in the workshop environment in a TVET college. It's for this reason that we have various illustrations. This is just one of the illustrations from this particular module. We have these illustrations to show the learners, apart from talking the mathematics and the scientific calculations based on these hydraulic problems, we want the learners to see and understand what these instruments and machines are. In the older textbooks, based on the older syllabus, the drawings were mainly done in sketch, without much detail. But we aimed, even if you look at this drawing, to give the learner as much details as possible. Because as we know, even looking at this picture here in front of me, calculations are based on the piston, the sliding ram, etc. It makes no sense to write this as a sentence and expect the learner to do the calculations without having a picture of exactly what these machines are. Module 6, stress, strain, and Young's modulus. The new content, compound bars are now included. Stress types, name the 3 main types of stresses. calculations on stress, strain, and Young's modulus. Unit 6.2, Young's modulus. Calculate change in length or total change in length for compound rods. It is one of the smaller topic weightings, which is 14%, and it's also a topic that has a lot of calculations, but not a lot of theory. Hence, 26 pages was dedicated to the content of this particular module. There is 15 fully worked examples, 3 activities, 1 summative assessment, the module summary, of course, video and resource links. Now, what we also found in this particular module is that learners really needed to be shown in a practical way what are the things we're talking about. Like, we often talk in class about a cantilever beam, and we don't understand what it is, or cantilever with a transverse load, for example. As much as we can try to draw it on the board or put a sketch, the best thing would be to see it in reality, and the second best would be to have photographs. In this particular module, there is quite a few photographs. We are trying to explain to the learners practically exactly what we are talking about. If you look at also this example, figure 6.1.5, when material is being punched or a pair of shears cuts through material. The nature of this module, there is different ways of asking questions, and we have 15 fully worked examples in this particular module. This would bring us to heat, unit 7.1, volumetric changes in solids. Calculate the volumetric coefficient of expansion given the linear coefficient of expansion. Calculate the change in volume and final volume due to temperature change. Calculate the percentage change in volume. Volumetric change in liquids. Explain the anomaly in the expansion of water. Calculate the change in volume and final volume. Calculate the change in the level of the liquid in a container due to temperature change. Calculate overflow in a container filled with liquid due to temperature change. Unit 7.3, volumetric changes in gases. State the characteristic gas law with relevant formula. Do calculations on pressure, volume, temperature, mass, and gas constant on all 4 different processes. Gas processes. Define the 3 basic gas processes: historic, isobaric, and isothermal. Sketch the PV diagrams. Do calculations on work done, change in internal energy and heat flow. Sketch PV diagrams of a maximum of 2 successive gas processes. Do calculations on work done, change in internal energy and heat flow for the 2 successive processes. Now that was quite a mouthful. I even have to take a deep breath before I change the slide. And for that reason, you will find there are 26 fully worked examples. I will say this again. It is very rare in an engineering book, or any book for that matter, to find as many as 26 fully worked examples. If you look at these slides that I've just read on heat and the extent of the syllabus, this was considered when the author wrote these 26 fully worked examples. We do not want to put the learner in a situation where he or she is searching the internet or searching some other resources to find answers. For an example, we do not want to put you as a lecturer in a situation of being under pressure, which undermines maybe whether you can teach or not. We believe you definitely can teach. It's for these reasons we have put these 26 fully worked examples in this particular module to make sure that we are covering the syllabus thoroughly. There's 4 activities. There's 1 summative assessment. There's 1 module summary. And of course, there are video and resource links. Now, I've extracted these two examples, 7.7 and 7.8, to show you in these 26 examples how we are covering the various scenarios and the various ways of an examiner asking a particular question. We don't want to put that learner in a situation where he or she goes to the exam and says, I have never seen this before. Every example has steps involved, step by step. We're not skipping any steps. We are telling you what the steps are. Example, determine the volumetric coefficient. The book is not written in the format where the calculations just follow each other without any explanation. Of course, it says for heat to draw sketch PV diagrams. In our book, we have a lot of diagrams, which makes it easier for the learner to reproduce these diagrams in the examination. Overall, this is one of the biggest modules with 42 pages and 26 fully worked examples. Okay, that basically it covers the content of the new syllabus and covers how the content was covered in Engineering Science N4. Now let's look at the assessment criteria. The ICAS trimester mark for Engineering Science N4 from 2022 going forward, 2 formal class tests for full-time and part-time students, or 2 assignments for distance learning students only. Now, it's very important for me to mention this part about distant learning. There are a few centers in South Africa that qualify as distant learning centers. A distant learning student and a part-time student are not the same thing. A part-time student is a learner possibly doing one subject or not attending all the lectures, but not classified as a distant learning student. When you enroll for distant learning, your code in the enrollment form is distant learning. Distant learning students are allowed to write 2 assignments instead of 2 tests. Whether you write the 2 assignments or whether you write the test, you have to obtain a minimum of 40% in order to qualify to write the final examination. Assessment marks are valid for a period of 1 year, as referred to as ICAS trimester marks. Now, for the sake of clarity, the 1 year actually means 3 blocks, so 3 trimesters. For example, if you qualified in the first block of 2022 and you failed the exam, but you decide to come back in 2024, your marks will still be valid for that trimester and for another trimester after that. Once 3 trimesters have lapsed, you would have to rewrite the test, or if you're distant learning, redo the assignments. Calculation of the trimester mark. The weight of test 1 or assignment 1 is 30% of the syllabus. The weight of test 2 is 70% of the syllabus. Yes, in the hard lockdown and when we were on level 3 and level 4, TVET did make adjustments for this weighting. But as it stands, for engineering science and for going forward, as soon as the new syllabus kicks off, the weighting will be test 1 30%, test 2 70%. The assessment criteria. The examination shall consist of 100% of the syllabus. The duration of the examination shall be 3 hours. The minimum pass mark or pass percentage shall be 40%. It is a closed book examination. The promotion mark, consisting of the combination of the trimester and examination marks, shall be a minimum of 40%. All right, to break it down further, the learner has to get a sub-minimum of 40% for his or her tests or assignments in order to qualify for the examination. Once the learner qualifies for the examination, the learner has to obtain 40% in the examination before any calculations of passing and failing can be done. If the learner does get the 40% in the examination, the combination of the test and the examination will give the learner the final mark. If the learner achieves 40% or greater, the learner will then have passed engineering science N4. Okay, looking at the title once more of the book, which is Engineering Science N4, we want to look at some of the features that our book has. At the beginning of every module, we have an overview and outcomes of the module. Considering how our new syllabus is written with specific learning outcomes, the outcomes of any module must be highlighted at the beginning of the module. And if you look here, we've taken pages out of the book. The overview will tell you your specific outcomes. In this example, module 1, relative velocity, solve problems dealing with constant linear motion. At the beginning of the module, the learner and the lecturer knows exactly what the outcome of this module is. The overview, we further go on to briefly explain. Sometimes it's in a real life situation, sometimes it's in a scientific situation. For this particular example, it says, kinematics is a science that deals with motion irrespective of forces. We have a photo of a person on a motorbike because we are talking about kinematics and motion. Now, what does this do for the learner? It starts immediately to encourage thinking for the learner. The learner knows what the topic is going to be. The learner knows right at the beginning, what is the objectives for this? What do I need to learn? What am I going to be assessed on? Outcome-based learning is a beautiful thing compared to how we were taught in the past. The learner was always in the dark. The learner had no idea what was coming out. The learner had to just stay along for the ride from the beginning of the module to the end of the module. We also have the starter activities, which I will discuss shortly. Special features, starter activity. The starter activity is designed not to have marks. It's there to immediately encourage and stimulate thinking in the learner's mind. For example, discuss the following questions in class. We're encouraging discussions. We're encouraging learners getting together. What does inertia mean? Does the tension in the cable supporting a lift differ? Further, in the starting activities, we try to incorporate real-life situations. For example, here from page 1, question 2, suppose you want to cross a river with a canoe and the water is flowing due south in the direction. In which direction would you steer the canoe if you want to travel at a 90-degree angle? So, in the starter activities, we also try to be very practical. Some of the starter activities, they have diagrams in it. It's very unique in that before you even get into the topic, the learner, just by having a discussion and having a quick think about something, already is on track with what the topic is about. Special features, examples with solutions. Now, to me, I studied engineering, as many of you have, and if you think about your engineering books, very few examples were fully worked. That is the truth. University level, even TVET level, the older books, steps were skipped out. We just jumped from the question, one line, and then we were gone to the answer. That is not happening in our book. If you look, example 6.1.4, a bolt is 400 millimeters long. Calculate the total extension of the bolt. We are not skipping any steps in between. We're giving the full answers right up until the final answer. This is a great tool for you as a lecturer. You do not have to search for answers for a particular question. The answers are all in the book. The activities, which I spoke about earlier, are spaced at strategic intervals in the module. For example, topic 1.1 is after you've covered unit 1.1. These activities all have a mark allocation. These activities are written in the format that you would find in the examination. So it's very formally written. The questions are well thought of, and these questions are all original questions by the author. At the end of a subunit, you can take this activity and you can test the knowledge of your learners. And as I mentioned before, you can even use these activities for setting your tests by changing, maybe the figures or changing the scenarios a little bit. Throughout this book, we have diagrams and figures all drawn on computer, no ambiguous or vague diagrams, clearly labeled, clearly dimensioned diagrams which were well researched. And we understand that learners cannot learn from text alone. Learners need to create a photographic memory in their brain, and these diagrams and figures help to achieve that. Throughout the book, apart from the diagrams and figures, we have real photographs of real situations to further help the learner understand and also put the learner in a practical situation. When we talk about a question, for example, calculating which way should the canoeist row, it's good for the learner to have a picture of a canoe in water to understand exactly what the question is asking. Throughout the book, we have definitions of terms and things like speed, the distance traveled during a time interval. So the learner doesn't have to wait and read the whole module and go back and search in a paragraph, where did I see speed? No, these text boxes are placed throughout the book. And it's also something that is very rare in an engineering book to find all of these definitions just popping up. But we know as lecturers, it's very important for the learner to understand exactly what a term means in order for them to do any calculations based on these terms. Our author, as mentioned, has been an examiner for many, many years. The author has put in exam tips throughout the book in every module. For example, this exam tip in the middle. Always write down the original formula first, then manipulate, then substitute in the given values. The author has great knowledge of where learners went wrong in the exams in the past. He knows exactly what is required in the examination for the learner to perform well. These exam tips throughout the book is really going to help the learner. Sometimes a learner forgets the smallest of things. For example, a radian is 57.3 degrees. These exam tips will help not only the learner, it will help you as a lecturer while you are teaching to remind the learners of these particular tips. We also have think about it question prompts. Think about it, if a gun is fired vertically upwards, what will happen to the bullet? We at all times want to encourage learning by thinking. So the learner is not, it's not a situation where you as a lecturer are just going to stand there and talk. No, there's got to be an interaction. There's got to be a learner thinking about a situation. So these, of course, are questions not for marks. It's there to stimulate learning. It's there to create the scenario and help the learner understand about a particular module. As I've been mentioning, these links to online resources. These videos on YouTube were well thought of and researched. There's other links in between, not only of videos, but of websites, for example, Beginner's Guide to Aeronautics. This helps the learners in their own time to go online. It also helps you as a lecturer to further research for your lesson plans and teaching. The summary of each module. At the end of every module, all the work that has been covered is summarized. Now, based on a lot of teaching theories, a summary is one of the most important parts of learning. At the end of it, it serves to recap for the learners to understand exactly what they have been taught. Remember, we have the specific outcome at the beginning and the overview at the beginning. At the end, we have the summary to recap and to summarize exactly what we have learned. Now, I've also found the summary helps a lot of learners who just particularly forgot one section. And by looking at the summary, everything, it comes back to them. It's a shortened version of what was covered in the entire module. It can also be a tool as a learner to tick off exactly what do you understand, what don't I understand. Let me go back and recap on a particular part. The summative assessments, similar to the activity, this is placed at the end of the module. You'll notice that they are longer than the activities. Like in this particular case, for module 1, the marks out of 80. It's based closely on examination questions. It'll help the learner to self-assess how far have they come, do I understand everything. It can even be used as you as a lecturer to base your tests and your exams around these questions. We have a glossary and symbols and abbreviations, as all our textbooks do. As we talk throughout the book about certain terms, and as much as we put as many definitions as we possibly can, it is very important to have a glossary to define and give the meaning of everything that we have spoken about in the book. We know in engineering and maths especially, we use a lot of symbols and abbreviations. If a learner is confused as to exactly what the symbol is, the learner can turn to the back of the book, in this case, page 243, and see exactly what each symbol or abbreviation means. Practice examination. Apart from our activities, apart from our summative assessment, the textbook also has a practice examination. This examination is set as the weighting of the syllabus is. So each section has the set amount of questions according to the percentages. It is out of 100. It's a great tool at the end of the course, as the summative assessments come at the end of the module. At the end of this course, the subject, the learner can write this practical examination to test how much have they learned, to test before the examination, am I ready for the exam, which part am I lacking? Lecturer's guide. Now you may have been wondering, as I've been talking about these activities and summative assessments and practice exams, etc., how are you going to get the answers? Well, the good news is, in our lecturer's guide, we have comprehensive answers. And once again, this is not your typical engineering book. Our answers on the back are not one-word answers. They're not just the final answer. For example, 25 degrees or 25 kilonewtons. No. Every question, whether it's activity, whether it's a summative assessment, whether it's a practice exam, every question has a comprehensive answer in this book. This is a tool that the lecturers will be using. You will not be lost as a lecturer. You will not be required to go and work out the answer for every single example, as we are giving the comprehensive examples in the book. Once again, there's links to online material to support your teaching. The practice exam and memo is in your lecturer's guide. There's a lesson plan template which you can make photocopies and use and put it into your portfolio of assessment. There's further a suggested 10-week teaching plan. I've added here in this presentation one useful website for past examination papers, which is mytvet.co.za. It's from my experience that this is a site that has the most subjects. Now, when you go onto this website, everything is free to view. It's not downloadable, but you can use it. You can go onto your laptop. You can take questions from there. And really, you'll find that there isn't a site that has as many previous question papers for all subjects. Also, I want to encourage any lecturers listening to this to please register for the TVET lecturing support system. This is run by DHET. It's supported by DHET. Basically, once you register for this online support system, there's resources available for your subjects. There's a whole lot of documents there. People are also uploading stuff that can help. So it's encouraging lecturers working together. As a lecturer, you are not alone. There's many people lecturing, for example, engineering, science, N4. So I want to encourage you to go on to this support system. Before I go on to the Q&A, I just want to wrap up here on the new book. It is very important points. This version of the book contains all of the changes to the curriculum. We have covered every specific change in the outcomes of the curriculum. Our author is a well-respected textbook author with over 35 years of lecturing experience. The lecturer's guide has comprehensive answers, links to online material, a practice exam, lesson plans, and a suggested 10-week teaching plan. Our new book has been completely updated. It's fully updated and aligns 100% with the new 2022 curriculum. Concise explanations to guide students through the curriculum, varied activities, step-by-step worked examples, figures, graphs, and photographs, alternative methods to cater for different learners, summaries and exam-type summative assessments at the end of each module, a practice examination, extensive lecturer's guide with activity answers, lesson and teaching plans is not also incorporated into this. Okay, at this point, I will just answer some of the questions that have been asked previously and possibly some that are on your mind now. One of the questions was with regards to the new syllabus and where can you actually get it. If for some reason your college curriculum department is not in possession of the new syllabus, it is a free to download document and freely available on the DHET website. If you don't have access to the website and you for some reason are battling to get that particular document, feel free to contact Gan or myself and we will do our best to email that to you. This presentation, yes, it is available if that question is asked, and the arrangements will be made with Gan for us to forward you the presentation. We also have done a detailed comparison of the syllabus. If you are concerned, how does the changes affect specifically? We can even get that document to you by request. Another common question was because of looking at the new waiting for the tests and examinations. It was only during COVID that the department made an exception where they adjusted the weighting of the tests. The current weighting is going to be 30% of the first test, 70% of the second test, which will make up your ICAS mark, and of course, your examination mark will give you the final mark, whether you pass or fail. Overall, I would like to say, do not have fear about the new syllabus. It's not there to change engineering science, but from what I gather by analyzing it, it is to put the syllabus in a specific way that outcomes are clearly defined, outcomes are clearly recognizable. It's there not to disadvantage the learners by setting things that are out of the syllabus. It's also there to support lecturers teaching, whereby outcomes are clearly defined. It's not ambiguous, and it was definitely a change that needed to occur in engineering science and in nature as a whole. I thank you, and I will just hand over back to Gan.
Thank you, Ruby, for a very informative and comprehensive presentation. I'm sure lecturers will benefit from all your advice, your content knowledge, and all the tips you've provided during the course of the afternoon. Yes, we'll make this presentation available to anybody that requires it. And yes, thank you. So if there's anything further, please drop us an email, and I'm sure Ruby will be happy to address your questions. Thank you once again for attending. Thank you, Ruby, for your time as well. Goodbye, everyone.